problem. So we've got the ladder.
And the alien.
Oh, we got an alien.
And the wall and the ground.
Okay, hold on a second.
And a distance. And a force. There's an alien. Hey, Courtney was very upset that you didn't use bunnies in your examples anymore.
I had problems with PETA. They called me over the summer.
Mr. Ray, did you know that the CEO of PETA wears animal furs?
Hey, you're not welcome.
Because where's that first? Yeah, I'm sure they do.
Hey, that's fine.
Where are you going, Joe? Are you leaving? Oh, okay. All right. Did you say check your email?
Yeah, I think that was guys for my Eagle Card might have
I think you need to focus on the task at hand. Okay. Shh. What now? What are you guys? I don't know what you're doing here. All right. Shh. Hey guys, quiet, please, quiet.
Do you really need quiet to draw pictures?
Yes. Okay, this is 1. Okay, what was the distance between the length of the ladder is what? 1.5?
1.5 and then 1.2
The alien and the, okay, all right. Shh. Okay. So this was already, we had force of gravity of the ladder and the force of gravity of the alien, right? Okay. So let's draw the free body diagram. The free body diagram looks like this, right? Okay, what are my forces on my free body diagram? Let's use it with variables, F, G, L, and then, okay.
And then you have your normal force.
From the floor, the normal force of the ground or the floor.
And then you have your force from the wall.
Okay, there's another normal force horizontally. Hey, kiddos?
Yes, sir.
Okay, focus. Normal force from the wall.
Force friction.
And force friction going what direction? To the right. Force friction. Okay? Everyone with me? Okay. So we've got our drawing and we have our free body diagram. And the free body diagram is important. Why is the free body diagram important to us?
You know your forces.
So you know what your forces are. Yes, sir. Of course. Okay. So we need to know what our forces are because what are we going to do with that once we know our forces?
We're going to add them all up to find our net force.
Okay, and we're going to create an equation, right? Yeah. So how many equations do we possibly have here?
2.
3. First two, one's going to be some of the forces in the x. The other one's going to be what? Some of the forces in the,
Y.
and the last one's going to be some of the torques.
Oh.
Okay? Some of the forces in the x. What are my forces in the x, guys? And actually, go ahead, I'm sorry, yeah.
The normal wall and the force of friction.
So the force normal wall plus the force friction. The understanding is that the ladder is sitting still. Why is the ladder sitting still, Matt Davis?
It's static. So in order to
What was the question that I had to find? What?
define the friction
Static.
and the friction, the mu static, and the
Yeah,
force.
Matt, I got it.
Yeah, she's got it.
He said what I had to find, so I'm telling you everything.
You.
Ultimately, I asked for the mu static friction, and the word static means it's not moving, so that the ladder isn't moving. That's what we can assume the ladder's not moving. So normal force wall and the friction force together must equal 0. Okay. What's the sum of the forces in the y? What are my sum of the forces in the y, guys?
Your F sub GL and then your F sub GA.
Is that all of them?
And then your force of
Normal force from the ground.
right.
Is everyone with me? Yes? Okay. Those are also going to equal a net force, and that net force is going to have what value? 0, because we're not moving. Now, I've got two equations. Let's talk about why I need a third one. Look at what values did I give you? I gave you what? What values did I originally give you? FGL and FGA. What is the FGL value? 15 to the 15 newtons, and the FGA is 10 newtons, okay? So I've given you two values. So in the first equation, the forces in the x direction, do you have either of those two values? Do you have the friction force or the normal wall force? No. So right now, that sum of the forces in the x direction equation is useless to you, isn't it? However, you need to ultimately use it. Why? Because what force is in that equation? Friction, and friction is going to involve the mu of static friction, right? Everyone with me? Okay. So now you could do this two ways. One, you could go right to a torque equation, or you could try and solve the sum of the forces in the y equation. The sum of the forces in the y, how many variables are there? One that we don't know. There are 3 total variables and only one that we don't know. So could I solve that equation? Yes. Okay. So we can solve that for FNGR, right? Okay. Okay, so what's FGL? FGL is negative 15 newtons, right? Plus a negative 10 newtons plus FNGR equals 0. So FNGR is what now? 25 newtons. Does that direction make sense? Does positive make sense? Does positive make sense?
Yes, because up and right are positive and down and left.
Yeah. Oh, well, the fact that the normal force on the floor is up, that makes sense, right? Yeah. Okay. Now, I can set up my torque equation, right? My torque equation, I'm going to come over here because it's going to be a little bit larger. I'm going to generate a torque from what forces on this ladder? What forces am I going to generate torques from? All of them. All of them. Some of those torques may turn out to be 0 value, but I'm going to generate a torque from every force. I'm doing this to make sure you don't forget, because you can shortcut. Yes, I get that. The problem is if you shortcut, you're going to rely too much on the shortcut and not remember how to solve this problem. These problems are all solved the same way. Remember, the key to physics is everything equals 0, right? But that's only if you add up everything. Okay? All right. Sorry, I had a really gross analogy, so I'm going to move on. Okay. So some of the torques. What are the? Let's talk about what. If I look at the sum of the torques, do I need to even at this point determine? If I'm just going to lay out the torques that I have, do I need to even determine at this point what I'm summing the torques around yet? No.
Why?
Because once I put the values in, then I'm going to go, because the torques, because every torque, because I'm going to write some of the torques, torque of this plus torque of that plus torque of this plus torque of that. Doesn't right now, no matter where I sum that torque around, it's going to be the same torques.
So when does it matter?
Once you get to the next level, when you start to decide what values you're going to apply, that's when it starts to matter. Watch this. So, because I'm giving you this sort of scaffold, this structure, right? And it's the same structure we've been using before. What are the torques on the ladder? Torque generated by what force? Call it out. Someone.
Due to friction.
Due to friction. Plus torque due to what? FGL, right? What else? Torque due to? N ground plus torque due to? F what? I have FR, FGL, FNGR. What else do I have? FGA. Right? I have FGL already. Plus, what's my last one? Torque due to F and W. Right? 1, 2, 3, 4, 5 forces. 1, 2, 3, 4, 5 torques. Follow me? Did you miss that,
And those,
Devesh?
those add up to 0 because it's not moving.
If my seesaw isn't unbalanced, moving, then it's going to be balanced. Now, could it be like this and be balanced? Sure. Right? It's not moving, but it's balanced. So if my torques are balanced, then the total torque is 0. Okay?
So this problem is saying that it's already not moving, and what mu is currently.
What mu do I need to keep it from moving? Think if this was ice, this ladder's going to slide, right? But I have to have some amount of friction so that with all of this weight, it doesn't kick out on me. And there's a minimum amount of friction I need, the maximum friction force, to have that happen, right? To balance those forces. Now we're looking at the friction from the other direction. Okay. So at this point, when I write this equation, it doesn't matter what point I'm summing the torques around. But once I start to break these things down, it is. Okay? It is going to matter. So here's the question. Right now, what's the strategy? What is the strategy about picking the point around which to sum the torques?
The numbers that you don't know have to equal 0. The variables that you don't know the force for, they have to equal 0. That way they cancel out, so you don't have to find
Okay. If I sum the torques around, so here's the beauty. The torque equations use the exact same forces as the sum of the force equations, right? So they're linked by the force values. If I can create an equation, though, because let's for a second assume I didn't have FNGR. Let's assume I didn't have that number, okay? Then I have 3 unknowns, okay? And I have 2 unknowns here and maybe a couple other knowns there, right? If I were to sum the torque around a point where one of the forces is at that I don't know, like I'm going to call this point A, point B, point C, point D. Point A, do I necessarily know FR? Do I know FR at this point? No. I know I solved for this number, but let's assume I didn't know that. That's 2 of them I don't know. If I were to put my point at A, if I sum the torques around A, then what's the torque generated, the actual torque generated by friction force and normal ground? How much torque do I have? 0. Because torque, again, remember torque is equal to force times the length perpendicular, the length between the actual force location and the point around which you are summing the torques.
And since those forces are acting on that point.
That distance, each length is 0. And therefore it knocks it out. So now I can have a torque equation with torque that I know, torque that I know, torque that I don't know, one equation, one unknown. You follow me? There's a strategy there. You want to try and knock some of these things out. Now, here's the thing. Because I know the value of 25, I could choose A, and that would leave me an equation with only one unknown. Or I could choose D, and it would still leave me an equation with one unknown. Right? Because if I currently know FNGR, then I'd have that point, right? If I were to put it around B, what would be the problem about putting the sum around B? I'd have the torque with 2 forces I don't know, FNW and FR. You follow me? Well, let's do the math, okay? So because I'll know the lengths, right?
So the torque at a point, you have to add up all the things on, or you have to use the stuff on either side of it.
The point is, I can have this ruler, okay? If I hold it here, there's one torque. It's the weight of the ruler twisting around my finger. Okay? The moment I try and support it, there are two torques. The weight of the ruler is actually, well, there's two torques, okay? Actually, there are three. There's a torque from my finger twisting around my hand. There's the torque of the weight trying to twist it around my hand. There's actually the torque of my hand twisting around my finger.
Right, but what I mean is, like, if you hold it up the way that you were just holding it, so your right hand, the torque at that point is not just going to be the forces that are at that point. It's the forces on any point on the object.
The torque around this point. So what we're doing is we're summing the torques around a specific point. So I can sum the torques around my finger here, my finger here. I can sum it around the end of the thing there. It doesn't matter, but you have to worry. You have to make that stake in the ground. Am I summing the forces? Am I summing the torques around point A, B, C, D, or any other point?
But if you're, I'm sorry, I'm still.
Yeah.
If you're talking about point A and you're saying that there are only those two forces and their length is 0. But then when you're talking about B, you were saying that there were
Okay.
more forces acting on it than there are at that specific point.
No.
At that point, there's only one.
No.
force.
No. What I'm saying is only one force. But what I'm saying is when I do the equation, okay, when I sum the torques around here, right? I'm going to have a torque generated by this, a torque generated by this, and a torque generated by that, right?
When you choose.
But I choose A. Choose A. Because these two go away. Because there's no torque, because the length is 0.
Okay.
If I choose this is great because now when I sum the torques, I'll have the equation where I have force and length, force and length. I know everything except for the force. One equation, one unknown. If I were to sum the torques around B, I would have this torque would go away, right? Because the length is 0 for FGL. But I'd have a torque from this twisting this way. I'd have a torque from that twisting that way. I'd have a torque from this twisting this way, and a torque from this twisting this way. And I'd sum them up. The problem is I'd have F that I know times L that I know, great. F that I don't know times L that I know, okay. But then I have another F that I don't know times an L that I know, that's 2 unknowns. And an F that I don't know times an L that I do know, that's 3 unknowns. And then I can't solve it. You follow me? Let me do it, and then let me do it once this way, and let me do it again the way that won't work, okay? So let's do this around A, okay? So torque around A. So let's look at the torque from friction force. The torque from friction force. Okay, that's the friction force times the length between the friction force and point A. What is that length? 0. Plus the force FGL. Okay, FGL, okay, times the distance between FGL and point A. Okay?
No, it's 0.75.
What is it? No, it's 0.75, but 0.75 this length.
That way,
Right, you want the perpendicular length. So
I think it was like.
I'm gonna call it this. I'm gonna call it LGL for the moment.
45 cosine.
Okay, but I'm gonna do it with variables for the moment, okay? LGL to A. Plus, what's the force? Normal ground. Force, normal ground. What's the length between the force, normal ground, and point A? 0, right? Everyone with me? It's at that point, times 0. Plus, okay, force of GA. That's force GA times the length from GA to A, right? Does that make sense? Right? Plus FNW times the length of NW, okay? I'm just putting variables in so we don't have to start doing the math at the moment. Does that make sense? And that's all going to equal 0. Notice that these two guys go away. So now I'm left with some numbers. Could I figure out the lengths? I can figure out all of my lengths, can't I, right? Some trig? So all my lengths I'm going to know. Do I know the value of FGL?
Yes.
And I can figure out this guy. Yes. Do I know the value of FGA?
Yes.
Yes. Can I figure out the length of GA to A? Yes? Do I know the force FNW? No. Do I know the length of FNW, or can I figure it out? Yes. So now I'm going to have one equation, one unknown. Okay? For a second, if this wasn't zero, if that wasn't zero, then I have two more unknowns.
I was just confused. I didn't quite get that you were that the only time that you would ever be talking about torque around point is whenever you're trying to utilize length. Like you said that it was in the next step, but I didn't get that.
Oh.
So I was getting confused about how you define around a point, because if you're talking about around a point, it could literally be like anything.
Yeah, but the distance, the length is the distance between that point
Right.
and the force. Okay, you're okay, good. All right, but you see why you would choose A versus B.
Right.
Okay.
Because you don't know any of the lengths around B.
No, I can find the
Except
lengths.
for the
I know the lengths. I just don't know if I choose B, then I have two forces that I don't know.
You can't solve it with more than 2 variables.
Right. Right now, look at. I put it around A. So the FR torque goes to 0. The FNGR torque goes to 0. I'm left with one equation, one unknown.
right.
If I were to choose B, then that would be my FGL. Well, that would go to 0, but that would not. That would not. So now I'd have 1, 2, 3 unknowns, and then you couldn't solve it.
Right.
Okay. All right. So now that I've got that, all right, let's do some trig to figure out my lengths. Do I need to go through the trig for you guys, or we can just get the numbers? So LGL to A, what's that distance, guys? So that's the LGL. This is my LGL to A right here, from here to here, right? That distance right there.
7.5 root 2.
Yeah, it's 0.75 times root 2 over 2, right? Cosine of 45, because I said the angle was 45 degrees. All right. So that equals what? What's my FGL value, by the way? 15 newtons. So it's negative 15 newtons times. Guys, did you do this problem or not?
Yeah.
Then pull out your notes so we're making sure we're there. So it's 0.7. It's yeah. Someone give me that. Someone give me the number. It's 45 cosine times 0.75, right? So it's 0.53.
Yeah.
0.53 meters. All right, keep that out, Devesh. All right, that's 0 plus 0 plus. What's my FGA value? FGA, guys.
That's -10.
Negative 10 newtons times what's my LGA to A? That's 1.2 times the cosine of 45, right? It's 0.85 meters, right? Plus my FNW times my LNW. And LNW is what? Now here's the thing. Where's my distance between the FNW and my point A? How do I figure, where is that, guys? You follow me, Kaylee? Here's my FNW. It's a vector. It can only move in the same direction it's going, right? So I can just bring it over. Let me get rid of this guy. I can bring that force over to here till it's perpendicular to my point A. Okay? So that's my FNW, and this is my LNW right here, from here to here. You guys see that? Yub yub?
Yeah.
Okay.
Wait. Oh, perpendicular, right.
Yeah. So that's going to be 1.5 cosine 45, which ends up being still again, it doesn't, what is it? So 45 cosine times 1.5 is 1.06 times 1.06 meters. You guys see this?
That's as far as I go.
Okay. Now, all you got to do is solve for FNW, don't you? Right? So 15 times 0.53. Oh, by the way, my lengths, are they positive or negative? Or-
I'm confused about that because you said, okay, but let me explain why I'm confused before you try to.
Wait, one at a time. Go ahead.
Okay, because you're saying, oh, if you go this way, it's positive, and this way it's negative. But what in relation to what? Because like
To
if
the
you're-
pivot point. To the point. To the
so, like,
point.
if you're saying, so you're saying pivot point. If it's
The point around which you're summing the torques. I'm
so
sorry.
the pivot point is right here.
The sum of the point you're summing the torques around.
Yeah, your pivot point.
Okay. Not always a physical pivot
Yeah,
point.
but and so it's going. So you're saying you have a force moving down here. If it's so you're saying it's going that way, then it's positive because it's to the.
Yeah. If this is my point that I'm taking the torque around, here's my torque summation point. Any distances, any forces to the right are going to be positive. Any forces to the left are going to be
So
negative.
for everything in that is positive except for the one that's going. down.
Correct.
But
Same thing for
it's
up.
though, actually, isn't it?
One of them's up, one of them's down. Now it's negative.
Wait, which one is up and down though?
The
'Cause there's
NW,
only, there's
the
only
NW.
one vertical one, isn't there?
Yeah. So look.
But
So
it's
if I'm a okay, the forces are going up, but the length. I'm looking at the length. This is up all about
No,
length.
go back to the other thing.
Okay, hold on. It's all about. I know. It's all about length. So any lengths to the right of the pivot point are positive. Any lengths that go up from the pivot point are positive.
Yes. So the one
So-
with the thing goes up.
So this one goes up,
So it's positive.
so it's positive. Does that make sense?
So everything there is positive.
So your
Yeah.
lengths are negative if they go left and
Okay.
down?
Because go back to the simple seesaw problem, right? Where I have a seesaw, okay? And I have a force here and a force here. F1 and F2, right? There's going to be a length 2 and a length 1, okay? This is going to give me a torque 2 and a torque 1, right? They're equal and opposite. They must sum up. T1 plus T2 must sum up to be 0. T1 is F1 times L1. T2 is F2 times L2 equals 0. What direction are the forces? What directions are both of the forces? Down. They should be negative numbers, right? Force down, negative, yeah? If that's negative, but they have to be opposite, because they're going to, let's say the forces and lengths are equal, okay? Then, and it's arbitrary, but we say to the right is positive. That means L2 is positive, so negative times a positive is negative. And I take that back. L1 is positive, L1 is positive because it's to the right. L2 is negative because it's to the left. Negative times a positive is a negative. Negative times a negative is a positive. Negative plus a positive is a 0. They're the same values. That's why you've got to do that. Okay? Otherwise, it won't balance. Okay. So now I've got this. And I have, okay, so negative 15 times 0.53 is 7.95 negative. So negative 7.95 Newton meters, right? That's the torque generated by FGL. Okay? Plus, that 0 goes away, negative 8.5 Newton meters, right? Yeah? Okay. Plus 1.06 times FNW. All that equals 0. So now I say 7.95 negative minus 8.5 is negative 16.45 Newton meters. So 1.06 FNW equals 16 point what? 45 Newton meters, right? Okay. There's a sign that somewhere is not correct. There's a sign that's not correct.
I know, I got a positive too.
I think it's correct because from the orientation it's a positive torque. So
No, but FNW should be negative.
yeah,
FNW should be negative.
Relative to the bar, it's pointing upwards. So
relative to the bar.
Yeah.
What bar?
Like the bar that the alien's standing on, relative to that, it's pointing upwards, kind of. So it means it's pointing
No.
up.
We should hold on. Let's double check. 15 is negative. 0.53 is positive, right?
Yeah.
Okay. 10 is negative. 0.85 is positive. Then it must be that up must be negative. That doesn't make any sense.
That doesn't make sense.
Doesn't make sense. No, it doesn't. Well, the magnitude is correct. The magnitude is correct. Where's my FR? Oh, FR is negative. Oh, that's why. Because I've knocked my FR out. That's the issue. Because FR is knocked out, there's no call for left or
It
right.
has a negative distance, so it's
Yeah.
positive force.
Yeah, it's a yeah. So okay, so let's for the moment. So FNW is going to be. I know why I did that. So FNW is going to that divided by 1.06. Okay, so it's going to be FNW is going to equal 15.51, but it's going to go to the left, right? 15.51 newtons, but it's going to be negative to the left because we know it's going to be negative. The reason it doesn't show up is because we've knocked out our only horizontal force, and at that point, it doesn't know which way to go. You follow me? Right. So we're just getting a magnitude.
It doesn't know anything. It doesn't have a brain.
It's true. That's very true. Okay. The other option is to solve it with just straight torque. You could actually not do this middle step here of F and Y and just do your torque, and I go to that standpoint. So now that I know that, now I can go into FNW, and now when I put that value into my sum of the forces equation, there comes the negative sign, right? So the sum of the forces in the X equal my FNW plus my FR. That's going to equal 0. So that means that negative 15.51 newtons plus FR equals 0. So FR is going to equal 15.51 newtons. Okay? 15.51 newtons. That means that's my friction force, right? So friction force equals what? How do I how do I break friction force down? It's
F normal times mu.
mu times my normal force. Do I know my normal force?
Yeah.
At the friction
Wait,
point.
I don't understand.
At the friction
At
point.
the friction point.
Yeah, right? It's the squeezing point of the ladder. So it's really,
No, you don't know it yet, do you?
it's
Wait,
15.51, okay,
but that's from the wall.
equals
though.
mu
Oh, that's the friction.
FNGR. In this case, it's FNGR, right? Times FNGR, which FNGR was 25 newtons up. 25 newtons up.
Wait, why is it times both of them?
What do you mean times both of them? Friction force equals mu times normal force of ground. I just called it different. There's two different normal forces. There's a wall and the ground.
Why do you do it in all force of ground?
Because where is friction acting on the wall of the ground? The ground. So that's the squeezing force. That's the normal force you're looking at. Yeah? So that means that mu of static friction is going to equal, 15.51 divided by 25, 0.62. Did everyone get 0.62?
I didn't get that far.
Okay. All right. You should be able to do that for the test.